Good morning, everyone. So, welcome you in today's class. We are doing quadratic equations. We have discussed very first exercise. What are the quadratic equations? Let's recapitulate that the standard form ax square plus bx plus c is equal to 0, where a is not equal to 0. So, we have to check that the highest degree of the equation, the variable that is 2, that is called your quadratic equations. So first let's start with the attendance part. So Vanshika, good morning. Ikrit, good morning. Sugandha Mishra, good morning bache. Simrandeep Kaur, 10A, Anmol, 10A, Parul, Sushant Mishra, Manpreet Singh, Vardhan, Anmol, Deep Kaur Chima, 10F, Arpita, Nandita Vasudeva. You all are welcome in my class. So very warm welcome. So today we will start the solution of the quadratic equations by factorization. Solution of quadratic equations by factorization. Right? So quadratic equations are always having two roots. Right? Always having two roots, and these two roots will satisfy the equation when we substituting the in place of x, then we are getting left hand side and right hand side both are equal, means left hand side become 0. Okay, so let's start with example number 3. Find the roots of the equation. Find the roots of the equation. Example 3. It is at page number 74. Page 74. Right? So statement is find the roots of the equation 2x square minus 5x plus 3 is equal to 0. 2x square minus of 5x plus 3 is equal to 0. So I have discussed with you that what is A and C. A is 2, C is 3. So here A into C, that is 6, and B is minus 5, so we can divide B in two parts, that is factors of one is 2 minus 2 and one is minus 3. When we multiply them, we get 6. When we add, that is minus of 5. So here, this implies that 2x square minus of 2x minus 3x by splitting middle term, minus 2 minus 3, that becomes, so here this further implies that 2x, so it is x here only, x minus 1, and here it is minus of 3. So this means we have the two roots, one is x minus 1 and another is 2x minus 3 is equal to 0. Now to find the roots of the equation, either x minus 1 is 0 or this one is 0. If x minus 1 is equal to 0, this implies that x is equal to 1, or if 2x minus 3 is equal to 0, implies that x is equal to 3 by 2. So here These are the two roots of this quadratic equations, right? So here we have the quadratic equation, right? 2x square minus 5x plus. Substitute the value of x as 1. So here 2 into 1 square minus 5 into 1 plus 3. So here it is 2 minus 5 plus 3, that is equal to 5 plus minus 5 is 0. So yes, this is the root 1 is the root of the quadratic equations. Similarly, substitute the value of, in place of 1, we can substitute the value 3 by 2 whole square, which is 5, 3 by 2 plus 3. So here 9 upon 4. So when we inside this 9 by 2 minus 15 by 2 plus 3, when we take the LCM here, when we are taking the LCM here, LCM is 2 and here we have 9 plus 6, that is 15 minus 15 is equal to 0. So what we say is that the two roots of this quadratic equations 2x square minus 5x plus 3 are 1 and 3 by 2. So I hope everyone this example number 3 is clear to you. Example number 4. Example number 4 is again example number 4 is 6x square minus x minus 2. 6x square minus of x minus 2 is equal to 0. So here 6 into minus 2, that is minus 12. So here a into c is minus 12 and we know the factors of 12, that is 3, 4. 4 should be negative here. So how we can write 6x square? Always we should go for the prime factorization here. 12 ones are 2, that is 6, 2, 3. So here 1 is 4 and 1 is 3. 3 into 4, 12. But here we need, that is minus of 4x plus 3x is equal to 0. So here we can take 2x common, that is 2x, then it is 3x minus of 2. Similarly here 3x minus of 2, but here we have to take plus 1. So what is the roots? To find roots, one is, that is 2x plus 1, another is 3x minus of 2. Right? So here we have either x is equal to minus 1 by 2, either 2x plus 1 is equal to 0 or 3x minus 2 is equal to 0. Because product of these two is 0, either this is 0. If this is 0, then what is x? Minus 1 by 2, and if this is 0, x is equal to 2 by 2. And similarly, in the same way, we can substitute the value of these roots here in the equation, we will find the value 0. Right? So here one value is minus 1 by 2 and another is 2 by 3. So let's come to example number 5. Here root 6 is used. I hope you all have understood these examples. Come to example number 6. So here some more students got their messages. Okay. Kamakshi, good morning बच्चे. Pratham Suri, then Nandita Vasudeva, Kushdeep Kaur 10A, Kavya Tehran, then Abhay Singh 10A, Arushi Birla, all are welcome in today's class. So I hope you all are fit and fine. And we have discussed only example 3 and 4. Today we are doing solution of quadratic equations by factorization. So by factorization we are doing by splitting the middle term. So example 5. In case if we are not able to factorize the equations, right? Quadratic equations, if we are not able to. Good morning, Parul. So here we have the equation number, that is question number 5, example 5, 3x square minus 3x square minus 2 under root 6x plus we have plus 2, right? So here the quadratic equation is 3x square minus 2 under root 6x plus 2. So here, how we can write twice of under root x 6? That is under root 6 plus under root 6. Or here it is minus of twice under root 6 can be written as minus of under root 6 minus of under root 6. Right? So this is the concept we have studied in grade 9 also. So this implies that we have 3x square minus of under root 6x 2 is equal to 0. Why? Because here 6 under root 6 into under root 6 is what? That is 6 only. So here 3 into 3, that is 6. So how to start? That is, we can take under root 3 common outside. Why? Because here we have to go for under root 3. So here under root 3 into under root 3x, it will get 3x square minus under root 2. Similarly here under root 3x minus under root 2 here, right? But here what we know, minus of under root 2. This is equal to 0 here, right? So what we have? We have the, in this case, under root 3x minus under root 2, and here under root 3x minus of under root 2 is equal to 0. So here the x is having two roots, they are not same, minus under root 2 by 3, 2 by under root 3, and here also there is under root 2 by 3. Or we can write even them as both, that is under root 2 by 3, right? So here the roots of these quadratic equations are under root 2 by 3. One very important thing, if I have to correlate here, you will find when both the roots of the quadratic equations are same. In the last exercise I have discussed in the beginning nature of roots. The nature of roots are decided by the discriminant. If discriminant is 0, 2 real and distinct roots, when the discriminant is 0, in this case you will find the value of discriminant is 0. And third case, no real root exists when this d is less than 0. So here we will check, because both roots of this quadratic equations are equal. Both the roots are equal. So here we will find this discriminant is b square minus 4ac. Okay, we will learn b square is 4 into 6. When you are going for minus 2 under root 6 whole square minus 4ac. So here is 24 minus 24, that is 0. So I have written the same example with the nature of roots. So three conditions we are having, right? So if any problem anyone is having So you can provide me the feedback so that I can explain, sir. Explain. Kavya Tehran is saying completing square method. So after solving the next topic, that is completing square method. Okay. So thank you, Kavya. Kavya Tehran is saying, sir, directly come to completing square method when we are not able to factorize a quadratic equation. It is difficult, then we can solve any quadratic equation. Okay, whether you can factorize it or not, we can solve it with the completing square method. And the completing square method is the basis for your quadratic formula. Quadratic formula. What is this quadratic formula? The nature of roots. The value of x is equal to minus b plus minus is b here upon 2a. What is b? The value of b, that is b square minus 4ac. Right? So here in your book, the proof of this quadratic formula is also given. So we will discuss. Okay, let me first complete this exercise 4.2. Right? 4.2, we can see exercise 4.2. Question number 1 is having 5 parts. Question number 1 is having 5 parts. So students are saying no, sir. So exercise 4.2. Let's take third and fourth part. Let's take third and fourth part. Third part, that is under root 2x square plus, that is 7x plus 5 under root. Right? So here, what we have, the quadratic equation is 2 under 2x square plus 7x plus 5 under 2 is equal to 0. So what is a into c? That is 10. What is a into c? Under 2 into 5 under 2 is equal to 10. And when we factorize 10, prime factorization is 2 and 5. So what is 2 and 5? 7 can be replaced 2 and 5. So here, this implies that under 2x square right? Splitting middle term, 7 can be written as 2 into 5. Now take common under root 2x can be taken outside, so it is x plus under root 2a because it comes in 2x. Similarly here x plus under root 2, but here we have to go common 5 outside is equal to 0. So what are the, one is x plus under root 2, one is from these two, and other is under root 2x plus of 5 is equal to 0. So what are the roots? The roots of quadratic equations are x is equal to minus under root 2 or x is equal to minus of 5 by under root 2. Right? We can even rationalize also. That is 5 under root 2 upon 2. What is it? This can be written as, that is minus of 5 under root 2 upon 2. That is one and same thing. So here, this is part 3 of the exercise, that is 4.2. Part 4, So I hope it is clear. You can provide me the feedback also. So Vanshika, all done. Thank you, Vanshika. Your feedback is very important. Question number 4 part, question number 1 4 part. Let me discuss here. A into C is 10 and we are dividing this 7 into 2 parts so that sum is 7 and product is 10. So taking common, we have the two roots minus 1 root 2 and minus 5 1 root 2. Minus 5 1 root 2 when we rationalize it, it can be written as minus 5 root 2 form. Right? So fourth part. So fourth part, the question is your x square minus x, 2x square minus x. Even we can write this equation as, if you are not able to understand how to divide or how to solve, it can be written as 16x square minus of 8x plus 1 is equal to 0. This equation and this equation, they are one and same thing. Why they are one and same? Multiplying this equation both sides by 8, we get the same equation. And it is very easy to. So before it, let me start here. This is 1 here. So what is 1? 1 can be written as, and what is A into C? 1 by 4. And here 1 can be written as minus of half plus minus of half. When you add, it is minus of 1 by 4. So when we add it, it is minus, this is minus of 1, and when you multiply these two numbers, it is 1 by 4. So I hope A into C and middle term minus of x by 2, right? So here take common, that is 2x here also, that is x minus 1 by 4. But here to get minus 1 plus, here we have to get 1 by 2 negative. So what we have? This further implies that we have one is 2x minus 1 by 2, another is x minus 1 by 4. So in this case also, the x here is, that is twice of x is equal to, what it will come plus 1. We can take better LCM here, that is what? 4x by 2 is equal to 0. So here, what is, this will become 0 here. So what is 4x is equal to 1, and this implies that x is equal to 1 by 2. And here also, if x is equal to 1 by 4. So the two roots of this quadratic equations are 1 by 4 and 1 by 4, right? Now when two roots are equal, we can check that b square minus 4ac is 0. If you want to solve in this way, then 16x square minus of 4x minus of 4x implies that, this implies that 4x minus 1 and here 4x minus 1. So here minus of 1 is required. So we have, this implies that 4x minus 1 into 4x minus 1. So the x is having two roots, 1 by 4, 1 by 4. This is all about your question number 1, right? The last part, that is x 100x square minus 20x plus 1 is equal to 0 is also easy one. So question number 1, last part. First two parts they are simple one you can do. Question number one, fifth part. Fifth part is saying 100x square, 100x square minus 20x plus 1 is equal to 0. So here AC is 100 and 20. We can easily write x 10x it is 10x right, 10 into 100x 10x minus of 10x minus minus will become plus here. So then again the value of x is equal to 1 by 10 in 1 by 10, right? So I hope this question is very clear to you. And then they are going for question number 2, solve the problems given in the example 1, right? So example 1 we have the two equations, right? One we have that is the John and Javanti are discussed in class here. The equation we have that is x square minus 45x plus 324. One is example 1. Here question number 2. Example 1 we have two parts. One is x square minus 45x x square minus 45x plus 324, and second, let me discuss the second example. Sorry, first example, second part, that the number of toys it was x square minus 55x plus 750. X square so here what is A into C? A into C 1 into 3 into 4. So how to factorize 3 to 4 prime factorization, and we will make 45 b1 b2 into parts. So here let's start 262 again with 2 81 then 3. So we have 2 into 2 into 3 into 3 into 3 into 3. But how to go? One factor is 2 into 162, right? What is it? 2 into 162, that is 324. 4 into 81, that is your again 324. And next, that is 12. 12 into 27, that is again 324. So many combinations. But here we want the difference of 2, that is must be 45. The difference of 2 that must be 40, that is minus 45. So here what can be 4, 12, 12 these are 36, 36 and 9, 40. So we can have one is 9 and one is 36, minus 36 and minus 9, right? So here we can go ahead like one is 36 into 9, but for our consideration we can take minus 36 and minus of 9, that is 324. So here we have learned how to go for this factorization method. So here this factorization method, right? This factorization method, we can write, this implies that x square, if you are taking 36 and it is up to you, that is 36x minus of 9x, but here what we have to minus of 9. So what we got, either x minus 9 or x minus 36 is equal to 0. So x is having two values, x is 9 or x is 36. These are the roots of or solutions, roots or solutions of this quadratic equations, right? Similarly, we can go for the second example. First example 1, or in fact exercise 4.2 question number 2. Here a into c is 175. In the same way that 175, sorry 750, that is 2, 3 2s are 6, right? 3 2s are 6, 14 and 5. Now with 3, right? And then we have 5 into 5 into 5. But how about 55? So again, that is 6, 30 and here 25. 30 and 20, 30 plus 25. So how to start? This is the question, x square x into, so here first split into parts. You can write anyone like minus 25, 30, whatever you want. Minus of 25x minus of 30x. You can write in any way. 25, then here you have to go for x minus 25, but here minus of 30, right? So this is equal to 0. So what we have, either x minus 25 or x minus 30 is equal to 0. Either this is 0 if x minus 25 is equal to 0, implies that x is equal to 25, one root is this, or if x minus 30 is equal to 0, implies that, right? So this is the second question. Now just an idea about the remaining questions. Question number 3 is find two numbers whose sum is 27 and product is 182. Find question is exercise 4.2, question number 3 at page number 76. Question is that find two numbers whose sum is, find two numbers whose sum is 27 and the product is 182. So how to solve? Let one number is x, one number is x, then another number another number, their product. According to question, what we have, x into x, 27 minus x, or here we have 27x minus x square is equal to 182. This implies that we can take this all right hand side, x square minus 27x. So please understand here that this question, right, or this equation, oblique this equation is one and same, minus of x square plus 27x minus 182 is equal to 0. There is no difference between these two equations. There is no difference between these two equations, and we can here again by factorizations can solve it. Here 182, when we go for factorization 182, so it is 91. Here that is 7, 30, these are prime numbers. So 27, 14 into 13, 1 is 14 and 1 is 13. Right? So here we have x square minus of, you can start with anyone, 13x, or x into, this implies that x into x minus 13, x minus 13 minus of 14. So what is it? We have either x minus 13 into x minus 14. So what is x? So we have the x is equal to 13, 14. So one number is 13, another is 14. If one is 14, another is 27 minus x. So both are the right value for this question. Similarly, we have, you can go ahead for these questions, question number 4, 5, 6 at go. Okay. Today I will discuss about the solution of quadratic equation by completing square, right? And like fourth question is also very simple. Find two consecutive positive integers, sum of whose is 365. What is it? The question number 4. Find two consecutive positive integers. Find two consecutive positive integers, right? Find two positive consecutive integers whose sum of whose square. The question is changed. Sum of whose square is so what are the positive integers? Positive integers are 1, 2, 3, 4. All natural numbers are positive integers, right? So here let one positive integer is x, so another can be x plus 1. Or you can write x minus 1. If one is x, another can be x minus 1. In both ways we can take. If you are taking one as x, then another is bigger one, and if one is x, another can be x minus 1. In any way you can take. But according to question, what are the square of? One is x square and another is x plus 1 whole square. So according to question, what we have, x square plus x plus 1 whole square. The sum of 2 square is 365. This is the statement. Right? What we have done, that one number is x, another is x minus 1. Right? Let one number is x, let one number is x, the other is x plus 1. Two consecutive positive integers. Two consecutive positive integers. So here we have, this implies that x square, or we have, that is 2x square, x square plus x square is 2x square, plus 2x. Now 2 is common in the whole equation. 2 is common in the whole equation. The equation can be written as x square plus x minus 2 ones are 2, 2 8s are 16, 2 2s are 2. So here again we have to go by factorization method. 182, that is what, 291, that is 7. So here 14 and 13. One is x square plus 14x, right? So here we have x into, this implies that x into x plus 14 into x plus 14 minus of 13 is equal to 0. What does it say? It says that one is x minus 13 into x can be 0. One of them is surely to be 0. To find roots, either x is equal to 13 or x is equal to minus 14. So minus 14 cannot be x. We are talking about positive integers. So here x is 13, so x plus 1 is 14. Right? X is 13, so x plus 1 is 14. So these are two numbers. One is 13 and another is 14. I hope you are clear with the question number 4. Question number 5 is about altitude of a right angle triangle is 7 cm less than its base and the hypotenuse is 30. Find the other two sides, right? So here we have to go for the Pythagoras theorem. Here we have to go for the Pythagoras theorem, right? What is given? Question number 5. One right angle triangle is given. In that right angle triangle, the hypotenuse is given 30. That is A, B, C, and the side that is 13 units, 13 centimeters. Let's take the relation between the altitude and the base. That altitude is 7 centimeters less than base. If altitude is x, base can be x plus 7. Or here if it is x, that is x minus 7. So it is up to you. You can even also get it in this way, that this is 30. If this is x, this is x minus 7. So in both ways we can go. If you are going here, then the equation will be x square plus x plus 7 whole square is equal to 13 whole square. And here if you want to solve in this way, x square plus x minus 7 whole square is equal to 169. Here x is the altitude. What is x? X is the altitude. But here in this case x is the base. What is the x? X is the base. So any way you can find and you will find the specific value for the altitude and the specific value for the base, right? So when you solve by any one, you will find that x square plus x square plus 14x 169. So here we have again 2x square plus 14x minus of that is 0 and 2. So again we can write that is x square to find 12 5s up. So here this implies that we have it is 12x minus 5x. So what is x? It is 60 here. This implies that either x minus 5 or x plus 12. So here x is equal to 5 or x is minus 12. So here in this case x is 5 and this is 12. So this is all about the question number 5. Similarly, we have the question number 6 about the statement of the question, that is a cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day the cost of production of each article in rupees was 3 more than twice the number of articles produced on that day. Now it is a statement question. You need to understand and you need to frame the equation. The total cost of production on the day was Rs90. Find the number of articles produced and the cost of each article. Right? So according to question, what is given? Let the number of articles produced in one day are x. What is? Time is almost over. Let's discuss only the sixth question. I can frame the statement for you. It's the last question of the exercise. Question number 6. Exercise 4.2. So according to question, let the number of the number of the article produced. Number of articles produced, they are x in numbers. Now, on a particular day, the cost of production is given 90. The cost of production of one article in rupees was 3 more than twice the number of articles produced on that day. What is the cost of production? Cost of production, that is 90. What is this cost? That is twice the number of articles plus 3. Right? Now, the cost, it was observed that on a particular day the cost of production of each article. Now, what is the cost of one article? That is this one. Twice the number of articles produced plus 3. The cost of one. This is cost of one article. So, according to question, x into cost of one. Number of articles into cost of one article is equal to, this is a statement of the question, and you can find the value of x. Right? So here 2 into that is 180. So when we can go for 180. Factorization is 3. So here it is 2, 90, 2, 45, and here 3, 15, 3, 5. So here we have, that is 4, 12 and 15. 12 and 15 is the right answer. So here one is 2x square. So we can write down here, that is 2x into x minus of 6, and here it is x minus 6, but here plus of 15. So we have either x minus 6, or here we have 2x plus 15. So the value of x, either x is equal to 6 or x is equal to minus 15 by 2. So negative x, the number of particles cannot be negative. So this is all about the question. I hope this exercise 4.2 is complete. Tomorrow we will start. If you have still any doubt, tomorrow we can take your doubts. Provide me the feedback. Tomorrow we will start the completing square method. Right? Thank you very much. God bless you all. All the best. Good day.